Greetings and salutations, magical chemists. Let's talk about empirical and molecular formulas. An empirical formula shows the symbols for the elements combined in a compound with subscript showing the smallest whole number mole ratio of the different elements. The molecular formula, on the other hand, is the actual formula of a compound, which shows you the total number of each atom in that given molecule. Please note that it is possible for the empirical and molecular formula to be the same. Let's take a look at a couple of examples. For example, glucose. The molecular formula, C6H12O6, is telling you there are literally 6 carbons, 12 hydrogens, and 6 oxygens in one molecule of glucose. However, if you wanted to simplify the ratio, all of those numbers, 6 and 12 and 6, can be divided by 6 and you still get a whole number. So the empirical formula, or the simplified ratio, is CH2O. It's a 1-to-2 ratio between the carbons and the hydrogens. All right, you should go ahead and try these other lovely example problems to make sure you remember how to go back and forth between the molecular and empirical. And when you're ready to check your work, unpause the video. And there you have it. Did you notice for sodium chloride, the molecular and empirical formulas are indeed the same? That is very common when you have ionic compounds. Now let's determine how you could calculate the empirical formula if you only know the percent composition by mass of each of the elements. The step-by-step looks a little complicated, but it's not too bad. And there's even a handy poem to help you remember the steps. And the best part is, the poem matches perfectly with the melody from Twinkle, Twinkle, Little Star. Percent to mass and mass to mole, divide by small, then multiply till whole. That's how you find the empirical smallest whole number ratio. Percent to mass and mass to mole, divide by small, then multiply till whole. You probably noticed that all of the information about how to calculate the empirical formula is actually found in the first 2 lines of the poem. The rest of the poem is just explaining what you're doing. There are 4 steps to follow. Now, you don't actually always have to do all the steps, so let's take a look at this. The very first step is percent to mass. So you're taking, if you're given the percent composition of each element, you're going to convert it into grams by just assuming that there's 100 grams of your sample, and it works perfectly. Of course, you don't need to do step 1 if you're already given grams. Step 2, super important, and it's easy. Just convert the mass of each element into moles. However, please be very careful. This is literally the #1 mistake that people make on empirical calculations, and it will lead you to very strange answers. You cannot round here. Our goal is to get to whole numbers, and we will by the end, but please do not round. Keep at least, I tend to just rule of thumb, keep my 3 sig figs. If you round, you're rounding too soon, and you're not going to get to the right empirical formula at the end. So don't round yet. Okay, third step. This is divide by small. Now, step 2, the rounding, that's the #1 mistake people make. Step 3 is the #1 thing people forget about. So step 3 is essential to get to the right answer. You can't forget about it. But all it means is divide each number of moles you have by the smallest number of moles that you calculated in step 2. All right, on to step 4. Step 4, multiply till whole, is only needed sometimes. If you already have whole numbers at the end of step 3, then you don't need to worry about this one. So after dividing by small, let's say most of your numbers are whole numbers, but then you've got some kind of decimal. Well, you can use this handy chart if needed to figure out what you would need to multiply to undo that particular decimal. All right, let's go ahead and try a practice problem and see if this makes any sense. So in our practice problem, we have a compound with phosphorus and oxygen only, and it has 43.67% phosphorus by mass. We want to know the empirical formula, and we want to name it. Okay, whenever you're doing an empirical formula calculation, you want to give yourself space to do a calculation for each element. Here, phosphorus and oxygen. Next, we start with the percentages. And if you recall, the first step in our poem is percent to mass. This is the easiest step, but you have to remember what to do, because if you don't, you'll just be sitting and staring. So here, we have 43.67%. We're going to pretend that I have a 100-gram sample, which means I'm literally just going to erase the percent sign and replace it with grams. I need to do the same thing for oxygen. They didn't tell me the percent composition of oxygen, but if there are only 2 elements, all I have to do is subtract from 100, and I can determine the percentage of oxygen. And of course, I will label that with grams. Now my next step is mass to mole. Well, hopefully you recall, dividing by the molar mass from the periodic table will convert our grams into moles. Once I've calculated the moles of each, I have a formula of sorts. I have a mole ratio. It's just not a whole number mole ratio. So to make these into whole numbers, to make it look like a formula we're more familiar with, we're going to go ahead and divide both of the numbers of moles by the smallest number of moles, which ends up being the 1.41. Now we have a better mole ratio, but we're still not quite at whole numbers. So to make sure every single number is a whole number, since I've got a 2.5, I'm going to have to multiply both numbers by 2, and I will have my final formula. And now we finally have our final whole number mole ratio, P2O5, or diphosphorus pentoxide. Before we continue onward into the calculation of molecular formulas, I want to make an important note. I'm aware that in pre-AP chemistry, this is something we learn in a unit and then we never really come back to it. This is a heavily tested AP concept. This will show up unit after unit after unit. So empirical and molecular formulas are something that you definitely want to make sure you're mastering from the very beginning. Okay, now that you're definitely paying attention, let's look at those molecular formulas. If you know the empirical formula and you know the formula mass of the molecular formula, it's actually really straightforward to determine the molecular formula itself. So please note, you must have 2 pieces of information before you can do this calculation, the empirical formula and the molecular mass. Sometimes they won't give you the empirical formula, so you'd have to calculate that first. Okay, let's try a practice problem. So we want to find the molecular formula for a compound with the empirical formula of H2O and a molecular mass of 54 grams per mole. So the first thing we're going to do is find the mass of the empirical formula. Sometimes, by the way, the molar mass is called formula weight, and so I abbreviate that as FW. And so the formula weight of water is 18.016 grams per mole. So now I just take the entire molecular mass and divide that by the empirical molar mass. When you divide this, you should get a whole number answer. That tells you the molecular formula is 3 times as big as the empirical formula. So I just need to take all of the subscripts from the empirical formula and multiply them by 3, giving me H6O3. And I'm done. There are 2 more practice problems on the page, number 3 and 4, but they don't contain anything new. So I'm going to strongly encourage you to try these on your own. Pause the video, see how they go, and when you're ready to check your work, go ahead and unpause the video. Okay, well, number 3 is a tasty problem indeed, at least if you like NutraSweet. You're given the percent composition of the different elements in NutraSweet, and you're asked to calculate both the empirical and the molecular formula. Of course, you realize that you have to follow the poem and calculate the empirical formula first, and only then can you go ahead and find the molecular formula. So let's find our empirical formula. Finding the empirical formula is fun because there are 4 different elements, but hopefully you realize you did have to multiply till whole in this example. And so you calculate an empirical formula of NutraSweet to be C14H18N2O5. Of course, we are not done. We need the molecular formula. We did need 1 more piece of information for that, but they gave it to you. The molar mass of NutraSweet, which is 294.30 grams per mole. So now we need to figure out, okay, that's great. What's the formula weight of the empirical formula? Did you notice when you added up all those fun masses together, you get the exact same mass as the molar mass of NutraSweet itself, which means the empirical and the molecular formula have to be the same. I mean, you can show it mathematically as well, because if you divide the formula mass of the molecular divided by the formula mass of the empirical, it's 1. And that's all you needed for number 3. Okay, one more to go. If you haven't tried it yet, pretty please try it on your own first, and when you are ready to check the answer, unpause the video. This process was very similar to the process for number 3, finding the empirical formula and then working towards the molecular formula. So our final formula was N2H4. And that's it. There you have it. So thank you for playing with all of the glories of